Okay, this is a quick review of two simultaneous equations. And two unknowns. First thing we're going to do with these equations is we're going to graph them. Okay, so graphing the two. The x-intercept of this equation is going to occur when y equals 0, so that 2x will equal 12 and x will equal 6. So we have the point 6, 0 on this graph. And if x equals 0, 3y equals 12, so that y is going to equal 4. So we have the point 0, 4 on the graph. And now we can sketch a straight line through these points, more or less. We do the same thing with this equation. First, let's label this. This is the equation that says 2x plus 3y equals 12. 5x minus 2y equals 10. If y equals 0, we get x equals 2. So that this graph will intersect the x-axis at the point 2, 0. Now, if x equals 0, y is going to equal negative 5. So that we have a y-intercept here at 0, negative 5. And now we can sketch a straight line, hopefully through these points. That's a little better than this one was. We can see that there's only one point that lies on both lines. Let's label this. Okay, whatever the coordinates of this point are, that's the values of x and y that make both of these equations true. So the x and y coordinates at this point satisfy both equations. So they're the simultaneous solution of these equations. Now I can estimate the coordinates of this point. Okay, if this is 2 and this is 6, then I think 3 would be about here and 4 would be about here. Now if this is 0, 4, then I think if I subdivide this interval from here to here, this is a little more than halfway, so I'm thinking that 2 is going to be about here, 3 is going to be about here, 1 is going to be about here. So based on my graph, my estimate, now remember I kind of missed this point, so I'm not going to get a great estimate. And I wasn't going to get a great estimate to start with because I wasn't totally careful about spacing the points and everything. Okay, but anyhow, it looks like this is 2 and this is 3, so this looks like about 2.6 or 2.7. So I'm going to go with 2.6. Probably should have gone with 2.7 because this line should have been a little bit higher, but we might as well make a mistake while we can. And this is real close to 2. I'd say about 2.2. So are those the coordinates that satisfy the equations? Well, let's see if they work. Okay? Now we got the equation 2x plus 3y equals 12. If these coordinates work, then plugging 2.6 in for x and 2.2 for y, as we've done here, should give us a result close to 12. Well, 2 times 2.6 is 5.2, and 3 times 2.2 is 6.6, and that's 11.8. That's pretty close. Closer than we had any right to expect. And if I'd have hit this point right, both of these coordinates would have been a little bit bigger, but we might have overshot the 12. So we'll take the 11.8. That's pretty good. Okay, down here, okay, we got 5x minus 2y equals 0. 5 times 2.6 minus 2 times 2.2, and it's not equal to 0, it's equal to 10. Okay, we get 10. Well, 5 times 2.6 is 13. 2 times 2.2 is 4.4. Well, that comes out to like 8.6 equals 10. Which is not great, but not terrible. Considering the hand-drawn graph and the perspective I have on the board and stuff. Okay, that's all good. We know that whatever the two numbers are, they're going to be pretty close to 2.6 and 2.2. Okay? Well, now let's go ahead and solve the system. This should be familiar. I'm going to call this my first equation. I'm going to call this my second equation. I'm going to multiply my first equation by, okay, I'm going to choose to eliminate y. I'm going to multiply my first equation by 2 and my second equation by 3, because if I multiply this equation by 2, I'm going to get a 6y. If I multiply this one by 3, I'm going to get a negative 6y. And my equations are going to be completely consistent with the original equation, completely equivalent to the original equations. Okay, so take the first equation and multiply it by 2. Well, that means I multiply both sides by 2. So I'm going to say that's 2 times 2x plus 3y equals 2 times 12. And then the second equation by 3 is going to give me 3 times 5x minus 2y equals 3 times 10. Now I wrote out this step because when I say multiply both sides by 2, a lot of times people put a 2 out here with no parentheses and they won't multiply everything by 2. You're multiplying both sides by 2. You're going to have to use distributive law to do that. So again, we have, now my equation I'm going to label as 1 and 2 again. It's not my original 1 and 2, but I'm going to label them as 1 and 2, since I'm not doing anything to them except applying the distributive law and doing some arithmetic. So I'm going to get 4x plus 6y equals 24, and 15x minus 6y equals 30. Now I'm just going to add the two equations. When I add the x's, I get 19x. When I add the y's, I get 0. When I add these, 24 and 30, I get 54. So that x equals 54 over 19. Okay? Now, 19 goes into 57 3 times. 54 is 3 less than that. 3 is about 1/6 of that. So I'm going to say that this is approximately equal to 2.8. Now we can compare that with my estimate of 2.6. And we see that 2.8 is perfectly plausible. Okay. Well, now we have to figure out what y is, so we take this value of x and we plug it into either of the two equations. So I'm going to bring it up here and plug it into the second equation, and that's going to give me an equation down here. Okay, 5x minus 2y equals 10. Now, I'm going to say that's 5, and I'm going to use the 54/19, not the 2.8, because that's clearly an approximation. We get 5 times 54/19 minus 2y equals 10. Well, we can solve this for y. What do we do first? We multiply both sides by the common denominator, if there's just one. So we get 19 times 5 times 54 over 19 minus 19 times 2y equals 19 times 10. Well, this can be arranged to give us 19 over 19. Note that I don't acknowledge cancellation in this course. 5 times 54 is 270 over 1 minus 38y equals 190. Now, the reason I don't acknowledge cancellation is people cross out anything, don't understand the rules for cancellation until I see that the whole class is going to the trouble to understand the algebra, the fractions, and we're going to continue to forbid cancellation. Okay? In any case, you see that 19 over 19 is just 1, and 1 times 270 over 1 is 270. So now we have 270 minus 38y equals 190. We're going to subtract 270 from both sides. I'm going to go through the steps of this because I just want to reinforce what we're doing. Actually, I'm not. I don't really have room. So I want you to write it out more thoroughly than I do. You subtract 270 from 90, you get negative 80. And then you solve for y. You get y equals negative 80 over negative 38, which of course is the same as 80 over 38. And that's approximately equal to 2 4/38, which is 2.1. So that compares pretty well with the 2.2 we had. If we'd have made the 2.6 into 2.8 and estimated the 2.2 as a 2.1, both of which are very plausible, we would have been even closer. Now, our estimates are not going to give us the exact fractions, okay? So y equals this. Now this fraction reduces to 40 over 19, which is about 2.1. So our solution, our exact solution, is x equals 54 over 19, y equals 40 over 19. The graphs intersect at the point 54 over 19 40 over 19, which is approximately equal to 2.8, 2.1. Now that's a procedure that I want you to imitate in detail for the homework.